ravens, there is food on the end of the line. Can the raven understand the connection between food, string and branch and grasp what to do? Just watch. Dr. Heinrich has added other strings with stones on to test whether the ravens understand what they are doing or just pull on a string and get lucky. If that was happening, it would get the stone as often as the meat. But it doesn't. As a final test of raven insight, Dr. Heinrich crosses the strings. The raven must study the problem and decide which string has the meat before it pulls it up. Insight was long considered a uniquely human trait, as was another activity that requires making plans in your head: the use of tools.
When I first observed a chimpanzee at Gombe using an object as a tool, there was a sense of disbelief among many scientists, because at that time we were supposed to be the only tool-using and tool-making animal. And the chimpanzees not only used little pieces of grass to fish for termites, but would sometimes pick leafy twigs and strip the leaves off, and that's the beginning of tool making. That single observation was a very exciting one, since when we've realized that the chimpanzees use many objects in many different ways, and they modify them very, very frequently.
If it's a sign of intelligence to use weapons, male chimps deserve respect. They fight using branches and sticks to threaten and impress others in their group. Stones are rolled and hurled, branches broken, thrown and shaken. The objects are deliberately used as instruments of intimidation. Even youngsters get in on the act. In between bouts of play, they select weapons to threaten, with varying degrees of success. And there are less aggressive forms of tool use. Leaves act as swabs for a wound. Or hygienic wipes. Tool use has been found in several groups of wild chimps. That may not surprise us, for they are our closest relatives. But do any other animals have the mental power to use tools? In only the last few years, crows have been discovered using tools here on the remote Pacific island of New Caledonia. There are large, juicy grubs in the rotten log. The problem is how to reach them. The crow searches out and selects the right tool for the job. Not any old twig will do, for the crow has a plan. Individual crows seem to have their own style of tool use, whilst others, perhaps youngsters, don't use tools at all. Some crows even redesign the tool for the specific job, shortening and sharpening the twig to gain a better grip. Using and even refining tools shows that crows understand the problem and can invent solutions. But does each individual have to solve the problem afresh, or can they also learn from each other? One of the most curious cases of apparent learning by imitation comes from Borneo. Here, orangutans and people mix at Camp Liki, a rehabilitation center in the tropical forest. No one trains or encourages the orangutans, for the purpose of the center is to return them to the wild. Yet despite this, orangutans turn up every day to share the camp chores. This animal seems to have learned how to do the washing, learning by imitation. But perhaps this is simple, mindless mimicry. Is this just aping without understanding, or true learning by imitation?
An example of true imitation would really require that the animal's performance, if not first time, very soon after its first attempt, was pretty well as good as that of a practiced performer. In the absence of an immediately good performance of that kind, then the possibility that the animal is simply using trial and error with an object to which its attention happens to be drawn is open, and we wouldn't have to suppose that this was a special new form of learning.
In Hawaii, Professor Lou Herman and his colleagues have tested dolphins to see if they can understand what they watch, and so imitate an action perfectly the very first time they are shown it.
Going in.
In the experiment, the dolphin on the left performs the action, which the other dolphin has to imitate. The dolphins receive instructions in sign language. The blue panel stops the imitating dolphin from cheating by seeing the left-hand dolphin's instructions. Can the other dolphin imitate perfectly from the outset?
There we are. Oh, there you are. Very nicely done, Phoenix.
The evidence is clear. Dolphins understand what they see, and so can imitate it exactly on the first occasion.
Interestingly, the dolphin is equally adept at imitating a human. So a human can act as the demonstrator in the water just like the dolphin has acted as a demonstrator. Or the human can be at tank side doing various behaviors. For example, a pirouette, nodding his head up and down, shaking his head side to side, lifting a leg in the air, and the dolphin does appropriate behaviors. It basically relates its body image to our body plan, even though the body plans are so different. So its tail, it perceives as an analogy to our leg.
Somersault, please.
So, some animal minds are capable of mapping their territory, solving novel problems, fashioning tools to help them, understanding other animals' behavior and learning from it. But what are the mental processes involved? To test whether animals have general ideas, concepts, scientists like Professor John Pearce of Cardiff University examine the mind of the humble pigeon. The pigeon learns that pecking at pictures of trees brings food, while pecking at other pictures does not. Food. No food. Food. No food. The pigeon learns the 30 pictures of trees that mean food. Now the critical part of the test. Professor Pearce gives the pigeon a new set of images. To recognize this picture that it has never seen before, the pigeon must have a concept of trees in his head. So, do pigeons have concepts? The answer is yes. The pigeon compares this picture with its mental concept of a tree and correctly rejects the fern. To test the generality of the pigeon's concepts, scientists gave them pictures by Picasso and by Monet. They quickly learned that only Picasso meant food. Could they form a concept of Picasso's painting style? The scientists presented the pigeons with pictures they had not seen before. They pecked at the new Picasso and rejected the novel Monet. Matisse's style is more like Picasso's than Monet's, so he got pecked. Art students often confuse Matisse and Picasso. It seems that pigeons do have concepts, and rather similar to our own. Could their minds really work like ours? To test that, Professor Pearce has given his pigeons and his students the same problems.
Today's practical is to give you a feel for the sort of experiments I've been doing with my pigeons, and what I want you to do, in fact, is to solve, or try to solve, some of the problems that I've given my pigeons. What I'm going to do is I'm going to show you a set of patterns on these television screens. Some of the patterns will be followed by a tone, and some will be followed by nothing.
The task is to predict which pattern is followed by a tone, and which is not. Join the students and pigeons and try and work it out yourself. Is this followed by a tone? What about this? And finally, this pattern. How did you do compared to the students and the pigeons? The pigeon may know a Picasso from a Monet, but it can't solve this task. It pecks hopefully at all the patterns, not realizing the answer is simple. Equal to. Now try to predict the answers in this next experiment. If you are struggling, you're not alone.
How many of you think you've got the solution to the problem? Oh dear, that's not many. Do some of you think you might have got it? No? Okay, well, I don't want to put any pressure on you, but by this stage, my pigeons are normally doing quite well.
And the answer? Small area of colour, tone. Large area, no tone. The pigeons find this task easy. They quickly discern the visual distinction between large and small areas. We, however, search for meaning, for relationships, and so fail to see the simple solution. The pigeons cannot grasp the concepts of equal or greater than. This is the realm of abstract thought and may be beyond the pigeon mind.
What if we have this many? No, we're going to pay attention to this. What if there's this many here? This many candies. You show me. Nothing.
So have we found the limit of the animal mind? Are they unable to think abstractly?
Okay, so let's try
Numbers are abstract.
this many.
Can animals count?
What if I put that many? What would you pick? 1. That's right. That was a good job. Boo. How many is that? Yeah, how many is that? Go ahead. Right. 2 things, right. Well, that's kind of a double one. Maybe we'll get another one. Okay, how many? Look at, oh, they're all over. They're going all over. How many is that? You ready? Okay. How many did you see here? Go ahead and tell me. That many? 6 is right. Oh, look, they're all over. That was an awful lot. Do you think you can eat that many? Can you eat that
It looks
many?
convincing, and it's not just Sheba that can count.
So good. They're so good, aren't they?
Tell me how many yellow
In
wool.
Arizona, there is Alex the parrot.
How many yellow wool? That's yellow. How many?
3,
No. Try again.
2,
2 yellow wool. Very good. Now how many green block? Very good. Telling me the yellow wool. Now how many green block?
4.
Good boy.
Alex's achievement in counting is remarkably impressive, and one has to concede that. On the other hand, there are questions we might ask about exactly what's involved in the sort of counting that Alex is doing, and we might illustrate that in the following way. I've flashed up there a picture of parrots, a collection of parrots. Now, anyone seeing that will instantly know there were 4 parrots there. Now, it's the fact that you know instantly, which is important in this example. You haven't systematically gone through and counted 1, 2, 3, 4. You've seen immediately. There's an immediate pop out of the number to you. And we know that in humans, we're pretty good at this up to a limit of about 7 or 8 items. That's about the limit to which any animal's been able to count successfully so far, which makes us think that perhaps the process they're using isn't the way in which we count when we're counting larger numbers of items. It's a simpler perceptual process, a process of vision rather than one of the intellect. If we want to see animals' counting abilities as demonstration of a higher intellectual ability, we have to go beyond counting to something like arithmetic.
Are you ready to do another turn? Okay. Will you go
Sheba
look
is
at your
counting the
pencils?
fruit in the
Look here.
tubs and being asked to add them up.
And look in here. Yeah, that and that. And you see these? Okay. Yeah, okay, now come and tell me how many you think there. How many were there altogether? I don't know the answer. You tell me. Go ahead. Yay!
Sheba's arithmetic prowess is startling evidence of abstract thought. But the most common demonstration of abstract thought is language.
I believe, and I believe a lot of scientists believe, that there is a really major difference between ourselves and any non-human animal, that we have a language system which they simply can't master.
Recently, evidence to challenge that view has come from chickens. The original bird brain. They have clucked and crowed under our feet for thousands of years, and all that time they may have been talking behind our backs. Dr. Chris Evans of Macquarie University, Australia, has studied their calls. He plays video clips to chickens in TV booths and monitors their reactions. When cockerels see a ground predator, they give a call and try to hide in the corner of the booth. When Dr. Evans shows them a hawk on an overhead TV, they give a different call and duck. Could the 2 calls refer to the 2 kinds of predator? To test this, Dr. Evans plays the calls to other chickens. On hearing just the aerial call, the chicken ducks. The call must mean something like aerial predator. Now the other call. All alone in its booth, the confused bird heads for the corner as if there is a ground predator nearby. Chickens are not alone in using calls that mean something. Meerkats have calls that refer to other animals. Animals which eat these small mongooses. Meerkats stand 20 centimeters tall and make a tasty snack for many animals, like the eagle. The eagle call. Now a jackal. The jackal call. A snake. And yes, the snake call. Each call does refer to a specific creature. They are, in a sense, words without a language. Some people suggest they indicate that these animals may have abstract thought, but Professor MacPhail has another hurdle for the animal mind.
Well, this charming little animal, like many animals, does communicate with its fellows from time to time, but the communications it makes are of a fairly restricted type. What we can do, and what they can't do, is to invent new words, new names for essentially any object or any event in the world.
What's here?
Can the animal mind use words as symbols as we do when we use language? Watch Alex with Dr. Irene Pepperberg.
What matter? Paper, good boy. That's right. Okay, what matter?
Whoa!
Whoa, very good boy. Okay. And what's this? Key is right. Say better. Key, good parrot. Very good. Can you tell me about this? What's here?
Rock.
Very good. Very good, Alex. Thank you.
Head down, down, all the way down. Go on in, lie down. Just head up, stay. Can you speak? Speak. And okay, wait.
Anne Head believes dogs understand English.
A dog can't speak to me. He can't speak. His voice is such that he cannot communicate with me, except physically. He can't verbally communicate with me. But that does not stop his brain working or his ears working. Now go jump in, pick up the string, head
Certainly
down.
Pippin behaves as if he understands Anne's every word.
Speak. Okay.
Irresistible. But to know whether the animal mind can really think in words, you have to do a test. Professor Herman and his workers in Hawaii use a sign language. The black goggles stop the scientists giving the dolphin any extraneous clues. Here, the dolphin is being asked in sign language to perform a task.
Good dog! Well done.
The dolphins are familiar with about 60 signs which can be combined to form thousands of sentences. The order of the signs in a sentence doesn't mimic the order of the action. This is a language with syntax. So to comprehend the command, the dolphin must grasp the sentence as a whole, including its word order.
I think one of the most interesting things we do is to study the dolphin's ability to understand what we call semantically reversible sentences. These are sentences which have exactly the same words in them, but in which word order is changed. Okay, Becca? Can the dolphin understand how the word order change affects the interpretation? So, for example, we have a sentence, right water, left basket, fetch. That's a 5-word sentence, and it instructs the dolphin to take the basket on its left to the stream of water on its right. This can be contrasted with another sentence, left water, right basket, fetch. Same 5 words, but we've changed the position of left and right. Now the dolphin must take the basket on its right to the stream of water on its left. It does this correctly and accurately and can do it, in fact, on the first occasion. That tells us that the dolphin understands that word order affects meaning. The dolphin's ability to understand represents a bridge between animal understanding of language and very, very advanced kind of understanding that we as humans have.
Most of us believe pretty firmly that some animals are cleverer than others, and almost all of us would believe that a dog in general is cleverer than a tortoise. One thing that we have also seen is that trial and error learning, the basis of, I would argue, all forms of animal learning, is common throughout the animal kingdom. So it doesn't seem to me that there's a major difference between vertebrate species in intelligence in general.
But these views are not shared by all scientists. The evidence from experiments on mental maps, problem solving, abstract thought and language suggests that animals do vary in their mental abilities, and that some minds may be similar to ours. But why are animals like dolphins and chimpanzees so smart?
I think the driving force behind the intelligence of the dolphin is the kind of world it lives in, particularly the social world.
And over 30 years of studying chimpanzees in the wild has led Jane Goodall to a similar conclusion.
For those large-brained animals that live in social groups, intelligence is extremely important because each of these other animals in your group has a personality and individuality, and you need to know exactly who's who in order to behave in an appropriate way. Not only must you know your own relationship to each of these other individuals, but you also need to know their relationships with each other.
The complexities of social life demand a level of higher intelligence in some animals. Not just chimps and dolphins, but parrots, crows and ravens live in intricate social worlds, as we do. Intelligence is just one aspect of the animal mind. Next week, we investigate the emotions. Do dogs get depressed? Parrots feel jealous? And peacocks fall in love?
And that next Saturday is at 5 to 6. Tonight's big film here on BBC Two is Spartacus, and one of its stars, Peter Ustinov, tells the story behind its making next.